Okay, today we are working on the equation of tangent lines. Today our equation is y equals 3x to the fourth minus 5 cubed plus 6 plus 8 at x equals 1. And for the equation line, we have this formula to work with and this one as well. Okay, to solve this problem, you have to plug in x equals 1. So for this, you get y equals 3, plug in the x to the fourth, same here, all the way down. Then once you plug in 3 to the fourth, 1 to the fourth is just 1. Multiply it times each other. Minus 5 plus 6 plus 8. So you do the PEMDAS and you get 3 minus 5, which is -2. And 6 plus 8 is 14. And that's how you get y1 equals 12. And that's where you plug it in to your coordinates. That's where you get x equals 1 and y1 equals 12. Now this is where it gets difficult. This is where you get y. You take the derivative of x to the fourth, which is 4x cubed. Derivative of x cubed is 3x squared. And derivative of 6x is just 6 because x equals just 1. And the 8 becomes 0, which is non-existent. Then once you get to that step, you distribute across the equation, and then you get 3 times 4 equals 12, x cubed. -5 times 3 is -15, x squared. And just bring down the 6. Then this was where you plug in the x again. You get y equals 12 to the 1 cube, which is once again 1, because 1 times 1 times 1 equals 1. Same for -15 times 1 squared is 1. And then you get plus 6. Then once again you do PEMDAS again, and you get 12 minus 15 plus 6, which is -3 plus 6, which equals 3. Then once you get everything, that becomes your m, the 3 right here. And then you just plug that in for m into the y minus 1 equation. So this is where the coordinates come into play. 1 minus 12 equals mx minus x1. Then once you get that, you distribute the 3x minus 1, which gets you 3x minus 3. Then once you do that, you bring to get y by itself, you add the 12 on this side, and that's where you get your equation, 3x plus 9. Now, if you come with me on this side, we have the same thing here. We get the equation y equals 2x to the cube minus 6x squared plus 5x plus 1. But this time we don't have x equals 1, we have x equals 2. So instead of plugging in 1, we get 2. That's where it becomes more difficult. So for this one, you plug in the 2 instead of the 1 for x across the equation. Then you get 2. You do the exponents first, so you get 2 cubed, which equals 8. 2 squared is 4, and 2 plus 5 is 10. You bring all those down. That's where you get 8. You plug it in for the equation, and then you get 16, because 2 times 8 is 16. -6 times 4 is -24, plus 10 plus 1 equals 11. And then you subtract that minus 8. and you get 3. Which because your y1, once again, you plug that into your coordinates, and then we back down to the original equation. Then we take the derivative of x cubed, you get 3x squared. The same for x squared, you get 2x. And then once again, 5x again, and you get just regular old 5. Then once you do that, you distribute. You get 6x squared minus 12x plus 5. And then you plug in the 2 that you had originally. You get 24 minus 24 plus 5. And then you just left with 5 for m. Once again, you come back to the formula y minus 1. You plug in your y1. You plug in your x from your coordinates. And that's where you distribute. Once again, you get 5x minus 10. And you subtract, you add the 3 to this equation right here. And you're left with y equals 5x plus 7. Thank you for staying with me in AP Calculus.